So I'm back with chapter 3, part 3, lipids. All right, so fats are lipids that are mostly energy storage molecules. So that is the main function of lipids. So lipids, they are insoluble, which means they do not dissolve in water. Water insoluble. They are hydrophobic. So that is one of our vocab words, hydrophobic or water-fearing. They are long-term energy storage, where glycogen is short-term energy storage. Lipids are long-term energy storage. They contain twice as much energy as a polysaccharide versus glycogen. So our body gets a lot more bang for its buck as a lipid than a sugar. They consist mostly of carbon and hydrogen, and they are linked. Non-polar, they have non-polar covalent bonds, so they share evenly, unlike water, which gives it its polar characteristics, which is why oil and water do not mix, is because one is polar and one is non-polar. Likes dissolve likes. Oil, like so I said, oil and water do not mix. Their bonding is different. Lipids differ from carbohydrates, proteins, and nucleic acids in that they're not huge molecules. They're not built from monomers. So we're going to spend 3 out of the 4 categories of macromolecules have this monomer polymer nomenclature. Lipids do not follow that. Okay, they actually have a lot of different structures. So we can see here, we've got glycerol, we've got a cholesterol, which is a rings. This is more of a branch. So we're going to talk about a couple of these, but they are very different. We are going to talk about in here 3 types of lipids. We're going to talk about fats, phospholipids, and steroids. A fat is a large lipid made from 2 kinds of smaller molecules. So we have this glycerol. This glycerol is basically a 3-carbon sugar. All right, notice 1, 2, 3 carbons and our water molecule on each. All right, then we're going to have what's called a fatty acid. Notice the fatty acid here, all the carbon and hydrogen bonds. This is non-polar versus our little tiny polar area, which is polar because of those oxygen atoms there. So what we're going to do with that glycerol and our fatty acids is we're going to actually attach them using those oxygens there. And so we have seen this type of reaction. This is our dehydration reaction. And so with that, we're going to pull out that water molecule, and we're going to actually, because we have 3 OHs here, we can do this 3 times. And so here is called what we call a triglyceride. Tri because we have 1, 2, 3 fatty acid tails, and then we have our glycerol backbone. Some fatty acids contain 1 or more double bonds. We call those unsaturated fatty acids, basically because they don't have as many hydrogen as they could possibly hold because of that carbon-carbon double bond. This does cause the molecule to kink or bend, and so we get some different characteristics because they cannot pack tightly. We actually get them more. These would be considered our oils. They're liquid at room temperature versus the saturated fats, which have the maximum number of hydrogens. They have all single carbon-carbon bonds, and they pack nice and tightly at room temperature, and they form your solids. So here is a picture of that. So notice our nice straight line here. They can pack very efficiently, and so at room temperature, we're going to get our nice fats. This is often our animal fats are saturated, which is why they're solid at room temperature. We have our unsaturated, which right here we have our carbon-carbon double bond that causes that molecule to kink. That kink will allow these molecules to not pack so nicely at room temperature. And so this is what we get for our oils. So these are our oils here. So like I said, unsaturated fats are our corn and olive oils. Most animal fats are saturated. We do have this term called hydrogenated vegetable oils, which are unsaturated fats that have been converted to saturated fats by adding hydrogen. So you guys have heard of this term called trans fats. So notice here we have our carbon-carbon double bond and our hydrogens are on the same side, and that's referred to as cis. Versus here we have our carbon-carbon double bond and our hydrogens are on opposite side, and that's where we get the term trans. When we talk about cis and trans fats are bad. And I'm going to talk a little bit more about this. So what happens is we take our liquids, which have those double bonds, and we add hydrogen to them so that we can get to a more solid substance. This is called hydrogenation. What happens is we don't get full hydrogenation. We get some partial hydrogenation. And when we do that, we end up taking that what was cis and turning it into trans. And so these products tend to have more trans fats in them that originally were there. We do this, for example, to make margarine. So, everybody struggled with the whole butter thing where you're trying to spread your butter on your bread and you end up decimating it because your butter is so hard. So we have that nice margarine spread that we use. And that has been made by hydrogenating the oils. Something else you may be familiar with is Crisco. All right, so your vegetable shortening, that's the same thing. That has the same process that was with fat hydrogenation. So when we look at those three types of fats, we have unsaturated, saturated, and trans fats. Unsaturated fats, so when we have our good, nice cis unsaturated, right? We are not holding as many hydrogen as we could because of that double-double bond. We've got some examples of some of those substances that are high in our unsaturated fats. They're very good. They actually raise your HDLs, your high density lipoproteins. You want that to be up, okay? That's your good cholesterol. Then we have our saturated fats. So our saturated fats, those, are animal fats. We can see here beef, butter, pizza. They tend to raise your LDLs. LDLs go up. Okay. Then we have our trans fats. All right. Now with our trans fats, what your trans fats do is they actually decrease your HDLs and increase your LDLs. So your trans fats are like a double whammy. They're just bad. They're really bad because they lower your good fats. They increase your bad fats. So that is why we want to stay away from trans fats. So that's the whole trans fat scare that you hear about. And then we have what are called phospholipids. So phospholipids, this is a major component. We'll talk about these in membranes, whether they're organelle membranes, cell membranes. This is going to be your borders for your internal structures. So this is really important. And so with our phospholipid, we have that here. Look, notice here is our 3-carbon glycerol backbone. We have our 2 fatty acid tails, but instead of having that 3rd fatty acid tail here, we have a phosphate group. And what that phosphate group does is it makes this part of the molecule much more polar. All right. This end down here is non-polar. And that sets us up for what's called a lipid bilayer. So with that lipid bilayer, what's going to happen is the inside, so the cytoplasm, and the outside of your cell has water. Its composition is mostly water. And so the heads, or the hydrophilic head, water loving, will face the outside and the inside. And the hydrophobic tails will all hide here in the middle. They're trying to stay away from the water. This creates a partition or a boundary for the cell. All right, so there's your hydrophobic tails. The last thing we're going to talk about with fats are your steroids. Now, your steroids tend to be these 4 fused rings, which we actually get those 4 fused rings from cholesterol. Poor cholesterol gets this bad rap, but we actually use cholesterol in our body for a couple things. We use it for hormones. We also use it for what I like to call your cell membrane buffer system. It makes sure that your cell membrane is not too runny or not too thick. So it has lots of different functions. So when we look at these hormones, and we already looked at testosterone and estrogen, so we saw that with our lions. We saw that backbone. We can see some of our functional groups that we talked about, our hydroxyl, our methyl group. You also hear a lot about these anabolic steroids. And again, anabolic means to build. And what we're doing is we're using synthetic variants of testosterone to build up muscle and bone mass. We actually do use anabolic steroids for some medical conditions. So, and again, these medical conditions would be where that person's health and livelihood would be at risk. And so this is something we use to slow down the progression of that disorder, versus an athlete who's trying to get an advantage over his competition. Problems with anabolic steroids are, and we hear about the violent mood swings, depression, liver damage, cancer, high cholesterol, and high blood pressure. So we can see this where we end up getting thrombosis, which is kind of blockages in the blood vessels. It also makes tendons more fragile and prone to tearing, cardiovascular disease, reduced fertility, and here's our mood change right here. Okay. All right, so that is it for this section on lipids. Do make sure you finish up the module, do your guided readings if you choose to, and I will hopefully have other things in there for you to look at. All right.